Okay, so like I was saying, we're going to be talking about transformations, specifically ones that deal with what's called rigid motion. So when you think of the word rigid, what do you think? Hard. Okay. Anything else, William? Straightforward. Rigid. It is kind of an interpretation of those two things. It doesn't get changed. So if you've ever met someone and they call themselves rigid, it means they don't change things easily. So when we talk about rigid motion, we're talking about a motion that does not change the shape or the size of what we're doing or what we have. And so we have three transformations that are classified as rigid, meaning our beginning shape and our end shape are the exact same. Which means we can say that our beginning shape and our ending shape are congruent. They have the same shape and size. So we're going to start with a translation. A translation is like a sliding up, down, left, or right. Normally when we see these, we're going to see something like x plus 2 comma y minus 3. When you see that, what you're going to be doing is looking at the x. Does anyone think they can read this and know what we do? Katie?
You add 2 to the x value, which is 5, and you subtract 3 from the y value, which is 2.
Perfect. So this right here is telling you what you're adding or subtracting. This is going to shift it left or right, depending on if it's positive or negative. So if this was a minus, we'd be shifting to the left. Since it's a plus, we're going to shift it to the right. The whatever's here is going to shift it up or down. So if it's positive, we're going to shift up. If it's negative, we're going to shift down. So if we were to want to find what's called A prime, which means our translated point, we would take 5, our original, and add 2 to it to get 7. And we would take 2, our y value, and subtract 3 from it to get negative 1. That would be our translated point. Okay, that's really all there is to translations. One way that sometimes translations will look is a notation that we have where they'll write a big T and they'll say 2 comma negative 3. That's a shorthand way to say exactly what's written there. So this here, it's positive, so we're going to add 2 to x, subtract 3 to y. So these are the same thing, they're just different notations for it. Okay, we also have reflections. Now we have two kinds of reflections. We have a reflection across the x-axis, and we have a reflection across the y-axis. So a reflection across the y-axis has the rule of x comma negative y. And so what that means is we're going to keep x the same and just make y opposite. So if I wanted to figure out what the reflection of my original A is across the x-axis, I would take my 5, 2, keep 5 the same, make 2 negative. So this would go to the point 5, negative 2. If we wanted to go across the y-axis, we would switch x up and keep y the same. So again, if we were going to reflect across the y-axis our original point, the 5, 2, the 5 would now become negative, and the 2 would stay the same. So if I went 1, 2, 3, 4, 5, up 2, I'd have my A triple prime that's reflected across the y-axis. Okay, I know it might not look it on this one just because my spacing is different on either side, but if you did this on a real graph, it would match up. Okay, so that's all there is really to translations and reflections. So when we're doing these, you're going to usually do a translation followed by a reflection, or just one at a time. So before we go into rotations, are there any questions you have on how we reflect or translate? Okay, so then rotations. For rotations, we have to make a couple of assumptions. First assumption is that you know what counterclockwise is. Do you guys know what counterclockwise is? Jesus? Rotating to the left. Okay, so think of a clock. The direction the hands go the other way. That's counterclockwise. Okay, when we talk about our rotations, everything is in terms of counterclockwise. So we are going to have to, and we'll talk about it a little bit later, we're going to have to describe transformations that we see, which means we can't just say, oh, that's a 90-degree rotation. We have to be specific about the direction. So we'd have to say 90 degrees counterclockwise or 90 degrees clockwise. So just be careful on your terminology of clockwise and counterclockwise. Okay, so I'm going to draw another set of axes. And I'm going to make sure I go 6 on all directions. Once I have that drawn, I'm going to draw a triangle, and this triangle is what we're going to rotate in all possible ways. So the first point of my triangle is A, which is at the ordered pair 1, 0, B, which is at the ordered pair 3, 2, and C, which is at the ordered pair 5, 0. So these are the 3 points of the triangle that I'm going to rotate. So our first rotation is going to be a 90-degree rotation. We have a rule to help us get the 90-degree rotation. If we take the x and the y's and switch them and then make the y negative, we'll get the rotated value. So we're going to use this rule to help us figure out what the 90-degree rotated figure would be. So if I start with A and I apply the rule, I'm going to switch x and y. So if my x is 1 and my y is 0, I'm going to go 0, 1. And then I'm going to make the y opposite. For B, I'm going to switch x and y, so 2, 3, and then make the y negative, or opposite. For C, which starts off at 5, 0, I'm going to switch, so 0, 5, and make the y opposite. Those are your new points for your 90-degree rotated figure. So there's no such thing as negative 0, it's still just 0. So we can go to 0, 1 and plot A, negative 2, 3 to plot B, and 0, 5 to plot C. And then when you connect the dots, you can see that you've rotated 90 degrees. Any questions before we go on to the 180 rotation? William. Okay, so the 180 rule says you just switch or do the opposite values of x and y. And that'll get you to the 180-degree rotation. So again, we're going to go to our original, 1, 0. If we were to take the opposite of both of those, what would we have? Negative 1, negative 0. But since there's no such thing, I can just write 0. What about B? Negative 3, negative 2. And C? Negative 5, 0, or because there's no such thing as negative 0. So if I were to go and plot these, negative 1, 0. Here's negative 5, 0. And then negative 3, negative 2. We'd have our 180-degree rotated figure. Okay, our last one is called a 270-degree rotation. Why don't we do a 360? 360 would be itself. So we only have the 3 rotations, 90, 180, and 270. So our rule for 270 is very similar to 90, where we switch the x and the y, but this time you make x opposite instead of y. And that'll get you your new points for your 270-degree rotated figure. So we're going to practice using this rule to find our 270-degree rotation. So we're starting with our original. So if A is 1, 0, I'm going to switch x and y, and then I'm going to make the x negative. Anyone think they know what B is going to be? Reagan? 2, negative 3. So we switch them and make the x negative. And what about C? Who thinks they know C? Analea? 0, negative 5. So then when we go to plot them, 0, negative 1. And then I have my C at 0, negative 5. And then I have 2, negative 3 for B. And we have our 270-degree rotated. Okay, this is where your patty paper can help you check your work. Okay, because these rules I'm sure are new to you. Has anyone seen them before? Yeah. Okay, oh good, they're not all brand new. That's awesome. The patty paper is there to help you check your work, but I really want you guys to get more practice on these rules, because after this class you don't get patty paper anymore. Okay, so You're going to want to make sure you know these rules that go with it, including the reflection ones, to make sure that you have them down for the test. All right, so any questions before we do an example of multiple transformations? Okay, so we're going to do one problem where we're going to look at doing multiple transformations in one figure. So I'm going to need to draw another set of axes. This one, we want to make sure it goes 8 in each direction. So when you draw it, you want to make sure you have enough room to go 8 in all directions. And so after you get that drawn, go ahead and draw this triangle. Because this is our starting figure that we are going to do some multiple transformations with. If you need help knowing what to draw, let me know. Okay, so when I start this, at the bottom here, I've written out what our transformations are going to be. We're going to start by translating to the right 4 down 2, or sorry, up 2, and then we're going to reflect across the x-axis. So this right here is the shorthand for how sometimes your transformations will work. Sometimes they'll write it out and they'll just say translate up 4 over 2. But other times they'll write it in this notation. So what we want to do is start with each point. So if I start with A, B, and C, and I want to make the translation. So if I were to take A and apply this translation, what are we going to do to apply the translation? What do we do to X? Add 4 to X and then add 2 to Y. So if we have -3 for X, what's -3 plus 4? 1. What is 0 plus 2? So this would be the translated A value. For B, B is at -3, 5. I know it's kind of up off the screen there. So if we add 4 to -3, we get 1. What's 5 plus 2? 7. Okay, now C. -5 plus 4 negative 1. 2 plus 2, 4. So this would be where our points are after we've translated them. But it wants us to do a second transformation. It also wants us to reflect. So our rule for reflection across the x-axis is to keep x the same, but make y the opposite. So if I now apply the reflection rule to our translated points, we keep x the same, but make y opposite. So what is our new point going to be? 1, negative 2. If we keep x the same and y opposite, what's the new point going to be? 1, negative 7. And lastly, if we do the same with c, so if I go and plot my final points, so 1, negative 2, 1, negative 7, and negative 1, negative 4. I have a figure that is translated and then rotated or reflected across the x-axis. So just to kind of recap, all of these three are considered rigid motion, and something about rigid motion that you want to know is that it maintains congruency. Okay, so it'll help things stay congruent. Okay, any questions on transformations at this point? Okay, I want you to look at your packet for 3.8a. Okay, on 3.8a, you're going to be doing these transformations and then answering some questions about it. So you have 1, 2, 3, 4, 5, 6 questions on 3.8a. Now, the other part of your assignment is 3.8b. So flip the page to 3.8b. I want you to cross off all the vocabulary stuff. Just cross it off. And I want you to go to the back side of 3.8b. I want you to cross off number 7. Okay, I only want you guys doing numbers 8 through 12. Okay, so this is where I want you to use your patty paper to help you. So on 3.8a, I want you to do that without patty paper. But for this one, this is where your patty paper is going to help you. What we're doing on these ones is we're trying to figure out what transformations happened in between one diagram to the next. So like if we look at number 8. I'm trying to figure out what did I do to get from this triangle to this triangle. What combination of transformations? Did we reflect? Did we rotate? Or did we translate? And this is where using our patty paper can help. Because if I were to sketch out my original triangle, DEF, oh, that's F up there. Now it's a lot easier for me to play with the different rotations and translations and so forth. So I could go, oh, this looks like it might be a rotation of 90 degrees counterclockwise, then a reflection, and boom, it hits. So this is where I expect you to use your patty paper, is to help you understand or figure out how you get from one figure to the next without having to sit there through all the rules. Okay? So like what I would do on this one is say I would rotate 90 degrees counterclockwise and then reflect across the y-axis. That got me to my new figure. Now number 8 actually has 2 ways you can get there, so that's just one of them. So that's what you're doing on 8, 9, 10, 11, and 12, is you're trying to figure out how did you get from ABC to DEF. So what kind of transformation did you do? Did you just reflect? Did you reflect and translate? Did you reflect and rotate? What did you do? Okay? And that's where your patty paper should come into play. So I'm only giving you the one piece, which means don't waste it on the problems where you have rules. Use it on the ones that you need it to help you with. Okay?